on the internet. So, thanks, Luke. Thanks, guys, for coming out today. As Luke said, I have quite a bit of information to get through, and I'm going to go a little quick because of that. If you don't catch anything, I'm going to have most of this stuff, if not all of it, up on my website shortly at www.35to65.com. It's about making 65 and then 35. All right, with that said, let's get started. Personal telomeromics. Can you turn back the clock? Talking telomeres, me. As you can see, we've got quite a bit to cover there. Telomere biology may be the most promising medical life and health span extending technology on the horizon today. The unlimiting potential of telomeres. Telomere biology has the potential to extend human lifespan to dramatically lower rates of the great remaining killer diseases: heart disease, stroke, and Alzheimer's. All three diseases increase exponentially with age, and their toll will be slashed as we learn how to address the body's aging clocks. It was no surprise to me. The science of telomere biology is the most important discovery in human history. We now understand the mechanism of aging and how to influence it. Life on this planet will never be the same. Clearly the most important biological marker for aging ever discovered, the telomere. If we can slow the process of telomere loss, the fundamental cap on how often your cells can reproduce might be removed or at least reduced. There are thousands of articles linking telomere shortening to disease and death, and that the chances of this relationship between shorter telomeres and higher mortality being random is 1 million times less likely than the chances of you winning the Powerball lottery. What are the odds of your growing ill and dying if you do nothing and allow your telomeres to erode? About 999 in 1,000. If I'd known I was going to live this long, I'd have taken better care of myself. Some factors in aging: telomere shortening, going along with chronological age, risk factors, oxidative stress, and location, which I'm sure you guys have covered in detail already. Life choices. What is your life worth? How often do you think of your health span and lifespan when you make the following choices? How much sleep to get on a regular basis? I know I don't do very well with that one. I'm not sure about you guys. How much exercise and what kinds to do on a regular basis? The food and supplement choices you make. Where you get your information on health from. Do you meditate regularly or not? Have you had your vitamin D or omega-6 to 3 ratios, if there's one I missed, tested on at least an annual basis? Do you know what your telomere length is, and have you checked it again a year later to see what direction things are heading? Whether you know it or not, each and every one of those questions relates directly to the length of the biological time clocks in your body, known as telomeres. What the gosh darn it are telomeres? Telomeres are sections of DNA at the ends of each chromosome that serve as protective caps to your genetic material. Every time a cell replicates, its telomeres become shorter. Shorter telomeres imply a shorter lifespan for the cell. See it jumps out of it? Yeah, exactly. Short explanation.
Kid, I was highly fascinated with aging, and I always felt that one of the greatest mysteries was how and why we age and what can we do about it. So to solve that mystery, I think will have a profound impact on our future health. So unfortunately, in the last 60 years since Watson and Crick, the maximum longevity of humans hasn't changed at all, and the expected lifespan of an American has maybe increased only 15%. So, and the current rate of increase is actually lower than it was back in the 50s. So this is a miserable reflection of our approach to age-related disease, and another example of Moore's law in reverse: more money and less return. So why did this happen? I think it's because the medical profession and industry both have been focusing on treating diseases rather than getting to what's the underlying causes of those diseases. It's like a handyman who's continually patching cracked walls rather than fixing the foundation. So we need to change our approach and address the root cause of age-related disease, which not surprisingly will reside within the mechanisms of aging. And this should lead to significant increases in both health span and maximum longevity, not by better treatments for disease, but by maintaining health and preventing disease from occurring in the first place. So that's a radical thought, but there's solid science behind it. It turns out that our cells have a built-in clocking mechanism, a cell division clock that ultimately leads to a suicide switch. We can see that clock at the ends of our chromosomes, the protective tip. So I have a low-tech model here of what's going on, and it may be the exception to the rule of complexity. So this was the subject of the Nobel Prize in 2009 about how telomeres play such a critical role in aging and age-related disease. So let's pretend that this is one of my chromosomes. It has a centromere at the middle, which is important for segregating replicated chromosomes between cells, and telomeres at each end. If this was to scale according to the size of that telomere, this chromosome would be about 100 miles long. So these are actually very small components, but critically important. So we know that every time a cell divides, due to a process called the end replication problems, telomeres get a little bit shorter. So here we are, I'm losing some of my cell division capacity. And notice that will later tell you that stress causes telomeres to shrink or accelerated telomere loss. So this is for the stress of giving a 10-minute talk. and in addition, we know that lifestyle changes, that lifestyle impacts telomere biology as well. So I missed my morning run, here goes a few more. And this is for the hot dog I had on the weekend. So of course the same thing is happening at the other end of the chromosome. So now I have a chromosome with critically short telomeres at both ends. And what this does, why it matters, is that this type of a chromosome is inherently genetically unstable. It's going to recombine, there will be further breakages within the chromosome, and this leads to loss of the ability of the cells to divide, and ultimately tissues start to fail, tissues and organs, and we end up getting a disease and die. So what can we do to address this issue? What are we doing to leverage telomere biology in healthcare? Well, we first discovered that short telomeres may be the best single biomarker of health and disease risk. And it turns out, in fact, that telomere length alone is a better predictor than most of the conventional biomarkers, and independent from it. I'm not saying that we would be looking at telomere length only as a diagnostic marker, but it would be used in combination with others. So monitoring telomere length may be a powerful tool for better health, encouraging individuals to adopt lifestyles that might slow the rate of telomere loss or potentially even activate telomerase, the enzyme that helps maintain telomeres, thus increasing telomere length and consequently lifespan.
Thanks, Cal. Thank you. Telomeres 202, the miracle enzyme of telomerase. The science of telomeres. Telomeres was first discovered in 1973 by Alexei Golodnikov. Telomeres and telomerase are relatively new, important, and dynamic areas of aging science. Telomeres are the structures, caps at the end of chromosomes, which ensure their stability during the process of cellular replication. Telomerase is a naturally occurring enzyme which lengthens telomeres when activated. Germ cells and stem cells express relatively high levels of telomerase. Many normal body cells express little or no telomerase. Each time a cell divides, the telomeres get a little shorter due to the mechanics of cell division. With aging, after a certain number of cell divisions, telomeres in a given cell get critically short. Older people generally have shorter telomeres. Diseases, stress, and a number of other conditions can also cause telomeres to shorten. Cells with too short telomeres can become senescent, unable to divide or replicate, or suffer apoptosis, die. These simplified facts have been known for a number of years and are uncontested. The goal then is to keep the telomeres as long as possible, thereby slowing down the aging process so that you not only feel younger, but you look younger, and you may even live longer too. See the telomeres right at the end there, the protective tips, and your double helix. Some adverse consequences of short telomeres: loss of tissue renewal capacity, failure of stem cell niches, induction of metabolic dysfunction, senescence-associated secretory phenotype, increased risk of cancer, genomic instability, which we're going to talk a little bit more about. The lifeline of telomeres. When a human is first conceived, the fertilized egg starts life with 15,000 base pairs. At birth, we've already lost around a third of our telomeres and are down to 8 to 10,000 base pairs. We lose roughly 50 to 100 base pairs of shortening yearly, or about 1,000 base pairs a decade. The average length of telomeres gradually decreases to about 3,000 base pairs. The critically short telomere designation often starts here, at which time the person's cells lose the ability to divide. These cells are called senescent, and the person suffers and dies of the diseases and ailments usually experienced in old age. Cells normally can divide only about 50 to 70 times the Hayflick limit, with telomeres getting progressively shorter until the cells become senescent or die. That said, telomere shortening and lengthening is largely a function of telomerase activity in our stem cells, which in turn is a function of genetics, taking a telomerase activator, which we're going to talk about, and holistic happy health habits. As you can see, telomere length declines as we age. Quoting the telomere pioneers: "The discovery of the telomerase gene as a central regulator of replicative immortality and the key that winds and sets the length of telomeres, and hence cell replicative lifespan in human cells, has led to great optimism about the prospects of turning on the gene in the body to extend telomeres and potentially human lifespan. If all processes of aging could be eliminated and oxidative stress damage could be repaired, one estimate is people could live 1,000 years." Why chromosomes have telomeres? Without telomeres, the main part of the chromosome, the part with genes essential for life, will get shorter each time a cell divides. So telomeres allow cells to divide without losing genes. Cell division is necessary for growing new skin, blood, bone, and other cells. Without telomeres, chromosome ends could fuse together and corrupt the cell's genetic blueprint, possibly causing malfunction, cancer, or cell death. Because broken DNA is dangerous, a cell has the ability to sense and repair chromosome damage. Without telomeres, the ends of the chromosomes would look like broken DNA, and the cell would try to fix something that wasn't broken. That also would make them stop dividing and eventually die. Telomerase counteracts telomere shortening. An enzyme named telomerase adds bases to the ends of telomeres. In young cells, telomerase keeps telomeres from wearing down too much. But as cells divide repeatedly, there's not enough telomerase. So the cells grow shorter and the cells age. Telomerase remains active in sperm and eggs, which are passed from one generation to the next. If reproductive cells did not have telomerase to maintain the length of their telomeres, any organism with such cells would soon go extinct. What effect does telomere length have on your health and wellness? Age-adjusted telomere length is the best method to date to assess biological age using structural analysis of chromosomal change in the telomere. Serial evaluation of telomere length is an indicator of how rapidly one ages relative to normal population. Therapies directed at slowing the loss of telomere length may slow aging and age-related diseases. The analysis of percentage of critically short leukocyte telomeres, less than 3,000 base pairs, has become a central validated biomarker that reflects biological, not chronological, human aging processes. Telomerase for the Nobel Prize. Can we turn back the clock? In the 1990s, there was a discovery of the enzyme telomerase, and it led to a Nobel Prize in medicine almost 2 decades later. For the prediction and discovery of telomerase, a remarkable RNA-containing enzyme that synthesizes the ends of chromosomes, protecting them and maintaining the integrity of the genome. Nobel Prize in Medicine, 2009. Testicular spermatogonia, sperm cells, robustly express telomerase, which allows them to continuously divide throughout life. By age 50, males produce sperm that have undergone approximately 840 cell divisions. Cancer cells also express telomerase in 85 to 90% of cases, which explains their immortality. In the remaining 10 to 15%, an alternative method for telomere lengthening is activated, called the ALT pathway. The most promising medical technology on the horizon today. Telomere biology has the potential to extend human lifespan, to dramatically lower rates of the great remaining killer diseases, heart disease, stroke, and Alzheimer's. All three diseases increase exponentially with age, and their toll will be slashed as we learn how to address the body's aging clocks. You would think that the 2009 Nobel Prize might have done more to raise the profile of research in telomere biology, but the field remains a specialized backwater of medical research, and few biologists, fewer doctors, take it seriously as a panacea for the diseases of old age. If the National Institute of Health has money to put into heart disease and cancer and Alzheimer's and Parkinson's diseases, there's no better place to invest than in telomere biology. Research on these diseases commands multi-billion-dollar budgets because they are considered medicine, funded by NIH, while telomere biology is considered science and funded by NSF. The total NSF budget for all cell biology is only $123 million, and the portion devoted to telomere biology is a mere few million. The private sector is doing a little better. There are several companies selling herbs that stimulate our own bodies to liberate telomerase, but this is short-sighted venture capital, and what we need is focused research with a 10-year vision. There's good reason to think that telomere length is a primary aging clock in the human body. The body knows perfectly well how to lengthen telomeres, but chooses not to. All we have to do is to signal the body to activate the telomerase genes that are already present in every cell. Of course, there's no guarantee that this will work, but compared to the sluggish rate of progress on individual diseases, it's a pretty good bet. And the target is rather simple. In my humble opinion, it's worth a cross-research effort. And this is in Josh Middledorf's humble opinion, not mine, necessarily. 3 objections raised against telomeres research. 1, aging is inevitable because physics tells us that nothing can last forever. 2, evolution has been working to maximize animal lifespans in order to increase fitness. It's unlikely that any simple adjustment to physiology that humans can discover will do better than evolution has done over millions of years. 3, expressing telomerase will increase the risk of cancer. We're going to address the third one shortly here. The first and the second one, answers will be available on my website shortly. There are no lab studies, to my knowledge, in which activating the native telomerase has increased the risk of cancer. The modern view is that while telomerase does not drive the oncogenic process, it is permissive and required for the sustained growth of most advanced cancers. Recent perspectives from both Harvard lab of the Pino and the Spanish lab of Glasgow focus on the potential for telomerase to decrease cancer risk. And these were the very people who produced 3 studies suggesting caution a decade earlier. And there are many studies showing A, telomerase expression does not increase cancer risk in lab animals, and B, short telomeres are a very strong cancer risk. I believe that telomerase activators will greatly reduce the cancer rate, first by eliminating cells that are pro-inflammatory and potentially carcinogenic because their telomeres have become short, and second by rejuvenating the immune system, which is our primary defense against cancer. Josh Middledorf published an article on this subject last year. Why we might expect big life expectancies gains from extending telomeres. Telomere attrition is an ancient mechanism of aging. As telomeres shorten with age in humans, people with shorter telomeres have a much higher risk of mortality. People with short telomeres have a higher risk of diseases, especially cardiovascular disease, after adjusting for age. Animals with short telomeres also have a higher risk of mortality after adjusting for age. In limited studies with mice, telomerase enhancers have led to rejuvenation. In addition to its function in lengthening telomeres, telomerase also acts as a kind of growth hormone. In one case, huge doses of herbal telomerase activators has led to rejuvenation. The bottom line, in my opinion, telomerase activation is a field that offers the most potential for human life extension in the next few years. This research is languishing for lack of funds and lack of attention. Telomerase in cancer and other diseases. Linking telomeres and disease. Patients with shorter leukocyte telomeres had a 3-fold higher mortality rate from heart disease and an 8.5-fold higher mortality rate from infectious diseases. Another study showed that younger individuals with shorter telomeres had a 2.8 to 3.2-fold higher risk of premature myocardial infarction. Other studies showed the same cardiovascular risk effect in older individuals. Finally, a study showed that peripheral blood leukocyte telomere length was shown to have predictive value as a test for advanced cardiovascular disease. More recently, telomere length was shown to be an independent risk factor for cancer. Telomere biology, cancer firewall, or aging clock. It's been a decade since the first surprising discovery that longer telomeres in humans are statistically associated with longer life expectancies. Since then, it has been firmly established that telomere shortening imposes an individual fitness cost in a number of mammalian species, including humans. But telomere shortening is easily avoided by application of telomerase, an enzyme which is coded into nearly every eukaryotic genome, but whose expression is suppressed most of the time. This raises the question how the sequestration of telomerase might have evolved. The predominant assumption is that in higher organisms, shortening telomeres provide a firewall against tumor growth. Do you want to stop now, Luke?
If you just have a incredible thing.
Okay. Telomeres do not cause cancer. Telomerase, the enzyme that lengthens them, does not cause cancer. The overexpression of telomerase in many but not all human cancers is merely another step in the cancer process. Turning on telomerase to lengthen telomeres may actually prevent cancer in the long run because it's the short telomeres that allow DNA in your chromosomes to fragment. This makes them more likely to cause the dangerous mutations we equate to cancer. This is one of the hopes for TA65. Talks about the alternative lengthening of telomeres, which we talked about. There's some studies. How to turn on your own fountain of youth by activating telomerase. There's some telomerase activation supplements that are already on the market. You can Google them. It's quite easy to find. Telomerase activation or telomerase activators. There's a debate on TA65 by some of the founders. There's some quickly some known telomerase activators. You were asking about epithalon or epithalon, which it's on the list. There's a bunch of other ones that you guys are probably familiar with. That list will be available on the website as well. This is talking about how our chronological age may soon be just a number. There's more on biological versus chronological age on the website. There's some recent headlines about telomeres, but we're not going to cover those today. Telomere testing, just quickly tell you what you're looking for. You want to make sure you're testing for the percentage of short telomeres, or rather critically short telomeres, not necessarily the average telomere length, as they've shown that the studies are much more accurate in predicting longevity based on critically short telomeres, and not just longevity, but your capacity or your tendency to come down with age-related diseases. To finish off, there's some slides on getting your telomeres tested, or if you get them tested. There's a place in Vancouver. They don't cover the critically short telomeres to date. I'm sure they will at some point. At the moment, they test for some of the other ones, which still have some correlations. And I would say that if you can't afford to go to the States or to another country to get your critically short telomeres tested right now, it would be not a bad alternative. In conclusion, some of the next things that we're going to talk about. Telomeres may be your next cholesterol. Everybody might be talking about that soon the same way, except that hopefully it will remain an accurate biomarker, not the other way around as the fear tactic. You sit too much, your telomeres may actually shorten. There's lots of studies about centenaries and telomeres, and I'm sorry Luca couldn't cover that because I know you wanted to talk about that one, but maybe in the future. Meditation, stress, exercise, and there's been a definite correlation to telomere length in that. Methylation and other natural T activators, another topic that bears talking about. Low-level laser therapy and telomeres, mRNA added gene therapy and telomeres. Specifically, this parish's Patient Zero BioViva trial, which apparently you guys were talking about earlier today. Last thing, it's time to slow down aging. According to some estimates, slowing the rate of aging just enough to postpone the age of onset of multiple age-related chronic disease by 2 to 3 years would save hundreds of billions of dollars in healthcare costs. Furthermore, lowering age-specific mortality rates from multiple causes by slowing the rate of aging may be easier to achieve than lowering them to the same extent by developing a separate, more specific intervention for each of a multitude of age-related life-threatening diseases, of which atherosclerotic heart disease, cancer, stroke, lung infections, and chronic obstructive pulmonary disease are among the most common. And for any information that we didn't cover in detail enough, or that I went over too quickly, it's at 35to65.com. Thanks, guys.
Thanks, Darren. This is awesome.